Hello everyone. Today we shall discuss about uniform circular motion and learn how we discuss this one, that is uniform circular motion. And today we will deal with uniform circular motion, and you see what are the main features of uniform circular motion. And here you see, today we will discuss about uniform circular motion and what are the basic factors in uniform circular motion that I am going to discuss. So we learn today about uniform circular motion, and you know that there is a online class every day on from 6 a.m. to 7 a.m. every day. So today we are discussing about uniform circular motion. You see what are the various things we need to know in uniform circular motion. You see, these are the various factors you need to know about uniform circular motion. There are fixed some thing that you have to know about uniform circular motion. You see, this is the uniform circular motion, and I already told you that there will be every day there will be online class from 6 a.m. to 7 a.m. uniform circular motion. Uniform circular motion. First, have to understand what is the meaning of uniform circular motion. After that, we can understand what are the various factors related with uniform circular motion. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. When an object, when an object, when an object, when an object follows a circular path, follows a circular path, circular path at constant speed, circular path at constant speed, circular path at constant speed. When an object follows a circular path at constant speed, at constant speed, the motion of the object, the motion of the object, the motion of the object, of the object, the motion of the object is called uniform circular motion. Uniform circular motion. This is known as, again I am telling you that when an object follows a circular path at constant speed, the motion of the object is called uniform circular motion. And we have to define two or three things. First one is angular position. Angular position, angular position. First, we will know the definition of angular position. What is that? Angular position. This you have to know. What is the meaning of angular position? Actually, angular position is the angle made by radius vector with a given reference line. Suppose this is a circle. This is the center of the circle. This is the radius of the circle. This is point A. This is radius. Suppose there is another radius, this one is another radius R, and this particle goes from A to B position, A to B. Suppose here t is equal to 0, at time t is equal to t, it goes at position B. And the length of arc is suppose S. This is S. That we can say that angular position is the angle made by radius vector with a given reference line. Angular position is the angle. Angular position is the angle made by radius vector with a given reference line. This is what we call angular position. This is angular position. Angular position is the angle made by radius vector with a given reference line. That is angular position. Now number 2 is angular displacement. What is that angular displacement? That you have to know. What is the meaning of angular displacement? Angular displacement, and it is represented as theta. So we can say that this angle is theta. Angular displacement. So we can say that angular displacement is the angle through which the radius vector turns for a given time interval on the circle. This is what we call it as angular displacement, and represent it by theta. You see, this is theta, right? Therefore, angular displacement theta can be written as angular displacement theta can be written in this way, that arc AB by radius. We can say arc AB as S and radius as R, or you can say that S equal to r theta. S is the arc AB, that we can find the length of the arc S in this way, that S equal to r into theta, and theta can be represented as S by R. What is theta? Theta is the angular displacement. If you know these various factors in uniform circular motion. And the next word what we learned about is average angular velocity. And number 2 is average angular velocity. Number 2 is average angular velocity. What is that angular average velocity? Actually, average angular velocity is defined as the ratio of change in angular position, del theta to a given time interval, to a given time interval del t, time interval del t. It is given as omega is equal to del theta by del t. Del theta can be represented as theta 2 minus theta 1, and del t is represented as t2 minus t1. This is average angular velocity. You have to know all the terms whenever we want to learn about these factors. First is angular position, number 2 is angular displacement, number 3 is average angular velocity. Number 4 is what we call it as instantaneous angular velocity. Number 4 is instantaneous angular velocity. Instantaneous angular velocity. Instantaneous angular velocity. Omega, we call it as omega. So we can say that instantaneous angular velocity omega, we call it as omega, is defined as the rate at which the radius vector of an object with respect to the center, with respect to the center on the circle, the circle rotates. That means you can say that instantaneous angular velocity omega is defined as the rate at which the radius vector of an object with respect to the center on the circle rotates. That is the instantaneous angular velocity. And written as omega is equal to limit del t tends to 0, del theta by del t, and this is represented as d theta by dt. This is known as instantaneous angular velocity. If you want to find what is the relation between linear speed and angular speed, we want to find the relation, then it would be relation between linear speed between linear speed and angular speed. And angular speed is given as b equal to r omega. B is equal to r omega, where b is the linear speed and omega is the angular speed. This relation you have to remember, that b equal to r into omega. Now we will define about time period and frequency. If capital T is the time period and nu is the frequency and nu is the frequency of particle, nu is the frequency of particle performing uniform circular motion, performing uniform circular motion, performing uniform circular motion, uniform circular motion, then omega is equal to 2 pi by t. You see here, suppose this object is moving in the circular way. It starts from A, reaches A, that is the distance is 2 pi, and time taken is t. Therefore, the angular speed will be omega equal to 2 pi by t. And you know that nu is relation, frequency relation with time period is 1 by t. You know this one. And nu is equal to 1 by t. Therefore, we can now written as 2 pi nu. Omega equal to either 2 pi by t or 2 pi nu. Right? Now we learn another thing, that is centripetal force. When an object moves in a circular path, there is a centripetal force acting towards the center. This is known as centripetal force. And the velocity of the object, direction of the object at any point is always perpendicular to this force, perpendicular to radius. This is the velocity of that particle. Therefore, we can say that a body undergoing uniform circular motion, A body undergoing uniform circular motion is acted upon by an acceleration directed towards center, This acceleration is called centripetal acceleration. This acceleration is called centripetal acceleration. Centripetal acceleration. And this is always acting towards the center. Suppose this is a particle moving in a circular path And here you see this is the object, the center. The centripetal force always acts towards the center. And the velocity of the object at any instant of time is always perpendicular to the radius. This is 90 degree. This is 90 degree. And since there is a force of centripetal force in this direction, there is acceleration also, because F equal to ma, you know that F equal to m into a, and the direction of acceleration is also equal to that of the force. So you can say that this acceleration is called centripetal acceleration, and centripetal acceleration can be written in this way: centripetal acceleration AC, centripetal acceleration, is represented by v square by r, v square by r, or you can write here as omega square r, omega square r. Omega square is v square by r square, the it will be omega square by r. So the centripetal acceleration will be omega square r. This is the centripetal acceleration. Where capital R is the radius, where capital R is the radius of the circle, radius of the circle. So what you know here, that the centripetal force always acts towards the center, and the velocity of the particle at a particular instant of time is always perpendicular to the radius. This is very much important. So you can say that a particle uniform circular motion, thus you can say that a particle in uniform circular motion, a particle in uniform circular motion, uniform circular motion has three main features: a tangential velocity, a tangential velocity with constant magnitude, with constant magnitude, These are the four main important features: a tangential velocity with constant magnitude and continuously changing direction. Here you will see that at every moment this particle is changing direction, because at every moment the direction of this particle will be perpendicular to the radius. You see, it is always perpendicular. So the direction is changing at every point of time. A tangential velocity is constant, magnitude is constant, but the direction is changing at continuously changing direction. This is the features of a particle in uniform circular motion: a tangential velocity with constant magnitude and continuously changing direction. Number two is only radial or centripetal acceleration directed towards the center of the circle. Only radial or centripetal acceleration, directed towards the center of the circle. directed towards the center of the circle, center of the circle. So only radial or centripetal acceleration directed towards the center of the circle. This is number 2. And number 3, this is also one of the features of circular motion. A constant angular velocity about the center of circle. Constant angular velocity. A constant angular velocity. A constant angular velocity about the center of circle. About the center of circle. Center of circle. So what you find here, you see here, there is a centripetal force toward the center, and the velocity of this particular law is perpendicular to the radius. So these 4 points are very important features of uniform circular motion. Number 1 is a tangential velocity with constant magnitude and continuously changing direction. Only radial or centripetal acceleration directed towards the center of the circle. And number 3, a constant angular velocity about the center of circle, constant angular velocity. And number the 4th one, a constant period of revolution. Number 4 one is a constant period of revolution. A constant period of revolution, and hence constant frequency revolution. Hence constant frequency revolution. Constant frequency of revolution. These are the important features of uniform circular motion. So these are the main features of uniform circular motion. What are the main features? See, a body undergoing uniform circular motion is acted upon by an acceleration directed towards the center. This acceleration is called centripetal acceleration, and centripetal acceleration is described by r, where r is the radius of the circle. This is a particle uniform circular motion has a tangential velocity with constant magnitude and continuously changing direction. And number 2 is a radial or centripetal acceleration directed towards the center of the circle. A constant angular velocity about the center of circle, and a constant period of revolution, and hence a constant frequency of revolution. These are the main features of uniform circular motion. So dear friends, if you want to learn these things, then you can download our app, and the app link is given in the description. So to learn the various important chapters of class 11 physics, download our app, and you'll find all the various chapters in detail. And here Arthur Levitt, he said, hello sir, So hello everyone, good morning, Arthur, and here we are taking online class every day from 6 a.m. to 7 a.m.